Assalamu alaikum warahmatullahi wabarakatuh. Welcome to our industrial automation lecture. I am Tanvir Saleh, your lecturer, and today we are going to discuss about programmable logic controller, the introduction to programmable logic controller. So without further ado, let us move on. Okay, when we talk about PLC, which is basically a digital controller, and when we say a small PLC, medium PLC, and large PLC, we mostly refer to the number of IOs it can handle. IO means input and outputs, and what is the maximum memory size of this PLC. So if it is within 128 IOs with 2 kilobytes of memory, then we refer to a smaller size PLC. And these PLCs are capable of providing simple and advanced levels of control. Medium-sized PLC memory can go up to 32 kilobytes, and the IOs can be as high as 2048. And the large PLC, which is used for large factories, can have an IOs 8192 IOs, and whereas the memory can go up to 750 kilobytes. And it can control individual production process and even entire plant. So this is for large scale PLC. Okay. Now this is basically architecture of any PLC. So you have a programming device that will be used to program the PLC. You have a central processing unit. You have this is important thing. You have a module input, and there is a module for output. So basically, inputs are connected to the push buttons, different types of sensors, and limit switches, whereas outputs are connected to basically solenoids, contactors, and annunciator, and all alarms, all such things. And you definitely will have power supply. So your input also can have analog and digital types. Your output can have also digital and analog types as well. Okay. So power supply is basically used to provide the power to the PLC. I/O modules are mostly used to convert and the logic level so that is applicable for PLC, and when it goes to the um, drive any actual output, it will also convert from PLC level to that is suitable for that particular output device. Okay, you have a central processing unit which basically does all the calculation and logic evaluation and all such things. Programming device is mostly now is the laptop that is used, or any types of computer that is used for most of the PLCs. However, in old days there used to be dedicated programming device to program the PLCs. That used to known as industrial terminal, program development terminal, programming panel, so on and so on. But nowadays, most of the PLCs can support any computer or laptops. So as I have mentioned, now computers can be used for PLCs to program. Okay, so the I/O modules, the purpose of the I/O module is basically I/O modules converts a signal from discrete to or analog input device to logic levels acceptable for PLC, and output modules convert signal from processor to levels capable of driving the connected discrete or analog output device. So one of the main jobs of the I/O modules, that whatever signal you have in the outside world, you convert it to a level that is applicable for the PLC processor to handle. Similarly, the PLC signal level should be converted to a certain level that output devices can handle that level. So this is one of the main jobs for the I/O module of the PLC. So in this case, this is a kind of zoom-in view of the I/O module. So you have a DC input module. In this case, you have your input device. It can be a push button, limit switch, or any discrete sensor. and you have to have a current limiting resistor followed by an opto isolator. So this opto isolator is helpful to isolate from the input to the PLC devices, so that if something goes in this side, this system, the PLC, which is expensive one, will not be hampered or will not be affected. And you have a buffer, filter, hysteresis circuit, all these things. After that, it will go to the processor to do the logic evolution. Okay. For the case of analog, you have an extra thing is called a rectifier, because as I mentioned, uh, basically PLC can handle DC supply. So that's why, and then followed by there's an opto isolator as well, and others remains the same. So basically this is for digital, it's basically opto isolator. So you have an LED and a photo transistor. So this is the isolation. So when this LED is turned on because of the input device, and this transistor switch will be also activated. So, and this is the PLC module. So this is the input going to the PLC module. So this is how this opto isolator is came into play in your PLC system. So this is your input from the outside world to, and this is the PLC. Inside PLC we have this opto isolator. But for the case of AC, you have to convert it to the DC signal first, because it is AC. So you have to have a rectifier circuit to convert it to DC, and then followed by there will be an opto isolator here as shown. For the case of output module, DC or out AC, so you have from the processor, you have a TTL circuit, transistor circuit, followed by an opto isolator again, and then it will be amplified to a level that the output device can handle. So there are different types of I/O circuits available in the PLC. Uh, so we call it pilot duty output. So this is one type of output that handles mostly high current electromagnetic loads such as solenoid relays and all these things. There are also, we have next one, general purpose output. So most of the outputs you will find it to be general purpose. So it is handling mostly low voltage, low current, such as normal light, indicator lights, or non-inductive loads. So for inductive loads, usually we use dedicated output which can handle higher current. For discrete inputs, this is basically digital inputs like sensor, which is on-off sensor, or limit switches, push buttons. These are used for discrete inputs. There are also analog inputs. So these analog inputs basically has a rating of 0 to 10 volt and 4 to 20 milliamp of current. So this one can be like pressure gauge, thermocouples, a strain gauge, so on and so forth. Can be used as well to interface with the PLC. Also analog output, that means you can drive your motor at, you can do the speed control of the motor, and you can do basically PID control of the digital implementation of the PID control through PLC as well, because it has D to A converter, and the rating is as follows. Of course, you will, after PLC, it has to go through an amplifier to drive the actual load. So this is basically a control signal, this analog output. So the difference between analog output and the digital output is that digital output is on-off signal. Analog output can have a variation of the voltage, which varies from 0 to 10 or 0 to 5 volt. There are some special purpose IOs which we will rarely use for our course. The circuits that, for example, is basically a stepping motor, PID controller, high-speed pulse counting, and all these things. But for our course, this is mostly out of the scope of our course. We will mostly concentrate on the general purpose IOs, not even analog output or input as well. Okay, so this is the input connected. You have push button, you have also output connected through the contactor to the motor. So the contactor will basically carry the high current, and you are going to turn on and off the contactor coil. So, and this is the lamp can be directly connected here, but motor, this type of motors you cannot directly connect it to the PLC. It has to go through the contactor. Push buttons inputs are connected to the PLC as shown here. So in PLC, we will have normally open push button, normally close, normally open switch, normally. Okay, what is the difference between switch and push button? Push button is basically spring loaded. That means you don't have to, you have to press your finger on the push buttons to make it open to close or close to open. For the case of switch, it is just, it's not momentary contact, but these are momentary contact. And when we describe it according to the PLC ladder diagram, we put it in this way. So this is normally open, this is closed contact, normally closed contact. So when this rung becomes true, then this normally open becomes closed. And when this rung becomes true, this normally closed become open. We will discuss these things more in next videos as well, inshallah. So as I have mentioned, this is logic 0, means it is false when the logic is 1, which is on. So you will basically run, this input will be driven. Okay. So this is analog input. So this is just to do some level indicator, maybe an can be an ultrasonic signal, ultrasonic sensor to measure the level of this water tank continuously, and this can be fed into the analog input of the PLC module. This is the digital output just to turn on and off the lamp based on some input which I have not shown here, and some logic evolution. You can turn on or off the lamp. For example, let's say you have a light sensor, and then you have when the light ambient light goes down, then you turn on the lights of the corridors. So this is an example of PLC to control any digital device. So you have analog also, so you can control these the valve opening and so that this pneumatic control valve, you can basically electric pneumatic transducer. So analog output is in an output signal that has a continuous signal, and typical outputs varies from 0 to 20 milliamps and 0 to 10 volt. So this is basically you may want to control continuous opening and closing, not just open and close. So it's basically the valve opening will be controlled in a continuous fashion. So so that is the example of analog output. Okay, so the processor is similar to a microprocessor of any type, so which is used for PLC. I'm not going to go very to details in this. This is quite self-explanatory as well. So in the memory, you have application and systems. The system memory includes the area called executive, composed of the permanently stored programs and some other things, which is basically occupied by the system. So and application is where you are going to store your program and instructions, and also the data, and also basically the input out. So those things will be stored here. So so you have application memory, and also you have system memory. So system memory is inaccessible. Mostly it is as designed. So you have volatile memory like RAM. So once there's no electric connections, the memory will be erased. So it's RAM, random access memory, similar to any computer system. You have non-volatile memory like ROM or EEPROM. For example, whenever you write a program, unless you overwrite it, so the program will remain there even if you turn off the PLC system, which you will experience in your lab course. So you will see that even if you turn off the power, the program will remain there. So that this is because it is an EEPROM system, so it is non-volatile. Okay, now this is very important. which we will be discussing the cycle of operation of any PLC system. So basically, when the PLC is running, basically first thing that it will do is read all the input. It will just scan all the input, first step. Second, it will basically do some program execution, followed by this program executions means whatever ladder diagram you have. So based on the inputs, it will do the program execution and do some diagnostics and communication within the individual components of the system. So this is related to your outside world. These two are related to your inside. So this outside world information will be taken into consideration and the program will be executed. Then it will do some internal communication and diagnostics that your system is working fine. Then it will again communicate with the output to the outside world through the output module. So basically it will change all the output. So whatever is input, based on the logic evaluation, it will do the output update. So now, as you can see, so it is not a really real-time system, so it is a sequential system. So we have to keep it in mind. So this cycle of operations, so phase 1, 2, and 3, 4. What is the importance of this? Let's say, this is what I have explained in the earlier slide. So once the typical phase 4 is complete, the entire cycle begins again with phase 1. So usually this cycle time takes about 1 millisecond to 100 millisecond. So it is not that fast. So 1 millisecond to 100 millisecond it takes about to take a single scan. That means phase 1 to phase 4. So that means if it is, let's say, 1 millisecond, so it's 1 kilohertz basically would be your scanning rate. Now if you have some input that is changing faster than this speed, then this particular PLC will not be able to detect that change, because it has to do the first scan, then it has to go through this whole cycle of operation, then only it can detect the second change. So your our input updating rate should be much slower than this cycle of operation. Otherwise, for very fast operation, PLC is not a good choice always. For very fast change in input, PLC will not be a good choice. You need high frequency data acquisition system in that case. Okay, I think that's all. If I'm not missing, let me see if I have a few more. Oh yes. So the PLC can be the communication, common use of the PLC communication port, basically uploading or downloading the program to the PLC. It is usually done by either USB or Ethernet cable through your laptop or desktop computer. And then this is the main communication we use. Sometimes you can use for monitoring data, alarms, and all these things. You can use operator interface units to do the communication, but this is the main communication that we will see for the PLC. Then I think that's all. Thank you very much, and Assalamu alaikum warahmatullahi wabarakatuh.